This is for section 3.9 homework, question number 11. Okay, a ladder problem. It says, a ladder is 15 feet long. I wonder if I can copy this picture. Hold on. Let's see if I can just copy the problem on my iPad by airdropping. I'm gonna try. Airdrop it to my iPad. Okay. So I got the problem copied here. So I'll go ahead and do the work on this tablet. Oh, what's going on? Oh, not the pizza picture. Hold on. All right, this is it. So let me do this. A ladder is 15 feet long, leans against a vertical wall. If the lower end is being moved away, also it's sliding down, huh? It's not safe. All right, hold on. Let me make this bigger. Oh, gosh. What? Ah, okay. So X over here, I'm gonna highlight this info. If the lower end is being moved away from the wall at the rate of 5 feet per second. So this is changing. Okay, what they are saying is dx dt is 5, is moving. Okay, the change in x with respect to time t is 5. How fast? And you know what's not changing is that the ladder itself is 15 feet long. Let me use a different color. So this is 15. How fast is the height of the top changing? This will be a negative rate when the lower end is 9 feet from the wall. So if you read this part carefully, the lower end is 9 feet from the wall. They're just telling you that x is equal to 9. They want you to solve this problem when x is 9 and the change in x with respect to time is just 5. What we need to find is, look at the wording very carefully, how fast is the height of the wall changing? The change in change in y, which is dy dx, dt. We need to find the change in y with respect to time t. So what do you look at? I mean, if you look at this picture, what do you see? It's a right triangle, isn't it? So the equation that they never gave us, that we need to differentiate implicitly, it's the equation using the Pythagorean theorem. Look, we have two sides. Remember in the Pythagorean theorem, if you square the legs and add them together, that equals the hypotenuse squared. So that is the equation. Now, I think I can go ahead and use this to find y real quick. Okay, let me find y. Let's find y. Because we're going to need to use it later. So x is, using this equation, x squared plus y squared equals 15 squared. 225. If I plug in 9 in here, that was the x value they gave us, I should be able to find what y is. So 225 minus 81 is 144. So y squared is 144. Y must be 12. So why did I find this? Because later on, we're going to use these pieces. dx dt is 5, x is 9, and y is 12. Okay, these will be plugged in. But now I have to differentiate that Pythagorean theorem equation implicitly with respect to t. So this is section 3.8, right? This is going to give us 2x plus 2y times dy dx all equals 0. Okay? You know my mistake here is that I was thinking what we did in section 3.8 and differentiated the left side with respect to x. I should not have done that. Sorry. I need to differentiate both sides with respect to t. So that's going to be 2x times dx dt plus 2y times dy dt equals 0. I was doing too many 3.8 problems. I forgot that the letter that we are differentiating this time is t. So both pieces will get dx dt and dy dt. Now we're almost done. All we have to do is just plug in all the pieces we know. Remember, x was given as 9. Dx dt was given as 5. Y, we found that piece. Y was 12. And only thing that we need to find is dy dt. So all I gotta do is solve for dy dt. If I multiply these three numbers, that's going to be 90. 2 times 9 times 5 is 90. 90 plus, and this is 24 times dy dx, dy dt. All that equals 0. And let's solve this for dy dt. Subtract 90 from both sides, I get 24 times dy dt equals negative 90. And if I divide both sides by 24, dy dt is, all right, let me try to simplify that fraction any further. Negative 90 divided by 24. What's that in fraction? That simplifies to negative 15 over 4. So dy dt is, where's the equation? Where's the okay. The height of the top is changing at a rate of negative 15 over 4. And what's the unit here? Negative 15 over 4. The unit should be feet per second. So it's sliding down. So 15 feet per 4 seconds. And that's how you can do this problem.